It's my pleasure to welcome this e-learning session. Let me introduce myself. I am Manishekar Arunachalam, who is working as a physics teacher in the esteemed institution Sri Vidya Mandir. The topic what we are going to discuss today is Electrostatics Part 1. Introduction. We all know well all the matters in this universe is made up of atoms. Atoms essentially consist of a central part called the nucleus, and the electrons and protons are present in it, where you know well that the neutrons and the protons are present well inside the nucleus and the electrons are orbiting around the nucleus. There are two types of charged particles, and they are protons and electrons. Protons carry positive charge of magnitude plus 1.6 into 10 to the power minus 19 coulomb and mass 1.67 into 10 to the power minus 27 kilogram. At the same time, electrons carry negative charge of magnitude minus 1.6 into 10 to the power minus 19 coulomb, and its mass is approximately 9.1 into 10 to the power minus 31 kilogram. We'll discuss basic properties of charges now. Like charges repel each other and unlike charges attract each other. When a glass rod is rubbed with the silk cloth, some electrons are transferred from the glass rod to the silk cloth. Hence, the glass rod becomes positively charged and the silk cloth negatively charged. Now, suspend two positively charged glass rods nearer to each other, and they move away from each other, and that helps us to understand that this positively charged glass rod repel each other. When an ebonite rod is rubbed with the fur cloth, electrons from the fur cloth are transferred to the ebonite rod. So, ebonite rod becomes negatively charged body and the fur cloth becomes positively charged. Now, you suspend charged ebonite rod nearer to this charged glass rod. It is observed that the two rods move close to each other, which implies that unlike charges attract each other. Now we will discuss the quantization of charge. The total quantity of charge present in an isolated system is an integral multiple of basic unit of charge. It may be expressed as total quantity of charge as capital Q, and small e stands for the basic unit of charge. We express the total quantity of charge with respect to the number of charges and the magnitude of electronic charge E as Q is equal to plus or minus Ne. The next property behind the charges is the charges are additive in nature. The total charge present in a body is a vector sum of individual charges present at various points. The charges are conserved. The total quantity of charge present in a system is always a constant. Now we'll discuss what is this Coulomb's law. You know, whenever the two similar charges kept close to each other, they shows a force of repulsion. When two dissimilar charges which may be kept close to each other shows a force of attraction. So it is necessary to understand what would be the force what is acting between the two charges. Coulomb stated the force between the two charges as follows. The force of attraction or repulsion lies between the two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. Let me consider Q1 and Q2 are the two charges which may be separated by a distance small r. So the force of attraction or the repulsion between the two charges is directly proportional to the product of the magnitude of the two charges. That is, F is directly proportional to Q1, Q2, and the force is inversely proportional to the square of the distance between them. So we say F is inversely proportional to r square. So combining these two, we write as the force of attraction or the repulsion lies between the two charges as F is proportional to Q1, Q2 by r square. To remove the proportionality, we have to introduce a constant k, and the value of the constant k is 1 by 4 pi epsilon naught, and therefore we say F is equal to Q1 Q2 by 4 pi epsilon naught r square, where this epsilon naught is called as the permittivity of free space. And if the same two charges were said to be separated in a medium of relative permittivity epsilon r, then the force will become F is equal to Q1 Q2 by 4 pi epsilon naught epsilon r into r square. But you know that epsilon is called as a permittivity, and the permittivity of a medium is nothing but the product of permittivity of free space and relative permittivity. So epsilon naught and epsilon r are replaced by epsilon. Therefore, you have the expression for the force between the two charges as F is equal to Q1 Q2 by 4 pi epsilon r square. Coulomb's law can also be expressed in vector form. Let me consider Q1 and Q2 are the two charges, and the charges are separated by a distance small r. Now we calculate what is the force on the charge Q1 by the charge Q2. F12 vector is equal to Q1 Q2 by 4 pi epsilon naught R21 square R21 cap. You should remember that this R21 cap is a unit vector, and this unit vector represents the direction. So let me say that R21 is the direction between the second charge and the first charge. Similarly, we calculate what is the force acting on the charge Q2 by Q1, and which is expressed as F21 vector is equal to Q1 Q2 by 4 pi epsilon naught R12 squared R12 cap. But we found that R12 cap is equal to R21 cap. R21 cap and R12 cap are equal in magnitude, but their directions are opposite. Hence we write as R21 cap is equal to minus of R12 cap. Substituting in the above expression, we say F12 vector is equal to minus F21 vector. It means the force exerted by the charge Q2 on Q1 is equal and opposite to that of the force exerted on the charge Q2 by Q1. So we say that Coulomb's law obeys Newton's third law. Electrostatic induction. Electrostatic induction is the phenomena of inducing charges on one body without any physical contact with the other. Look at these illustrations. In the first illustration, consider A and B are the two metallic spheres which are placed on insulating stand as shown. Let me consider a positively charged glass rod is now brought nearer to the sphere A. It is observed that the negative charges are induced on the nearer side and the positive charges are induced on the further side as shown in the figure 2. Now, in the presence of the positively charged glass rod, the spheres are separated as shown in the diagram. Even though the removal of the positively charged glass. Now we go to the illustration 2. Consider a negatively charged plastic rod is brought nearer to a metal sphere. It is observed that positive charges are induced on the nearer side and negative charges on the farther side. Now the metallic sphere is grounded as shown in the diagram. Now some of the negative charges are flown to the earth and leaves the metallic sphere with positive charges. Now the removal of the negatively charged plastic rod, we found that the positive charges. Now we will discuss electric field. The space around the charge where its influence is felt is called electric field. Let me consider a test charge Q is placed in an electric field. You know, whenever a charge placed in an electric field will experience a force, and the force experienced by a charge placed in an electric field is given by F is equal to QE. From this, you can define what is this electric field E, and E can be expressed as F by Q. It means the electric field intensity at a point is the force experienced by a unit positive charge placed at that point. The electric field is measured by an unit Newton per Coulomb. Let me discuss what is this electric field due to a point charge now. Let me consider a point charge Q is placed at a point O. Let me consider a charge of 1 coulomb is placed at a distance r from this charge Q. We already discussed about Coulomb's law. Between the two charges there must be a force, and the force between the two charges is expressed as F is equal to Q into 1 coulomb by 4 pi epsilon naught r square. Rearrange this expression. F by 1 coulomb is equal to Q by 4 pi epsilon naught r square. We studied the force experienced by a unit positive charge is electric field. Therefore, we express the electric field intensity as E is equal to Q by 4 pi epsilon naught r square. So, it was very clear that the electric field intensity is inversely proportional to r square. On plotting a graph between electric field intensity and the distance r, we observe that the electric field intensity decreases with respect to the distance, and it is illustrated in the diagram. Electric lines of forces. What are electric lines of forces? We studied that whenever a charge placed in an electric field, it experiences a force. When the charge experienced a force, it started moving from one point to another point. Now, let me come to this point, electric line of force. The path followed by a unit positive charge placed in an electric field is called the electric line of force. Let me discuss the properties of electric lines of forces now. For a positive or a negative charge, the electric line of force is either a straight line or a curve. For a system containing positive and negative charge, the electric lines of force starts from the positive charge and terminate at the negative charge. No two lines intersect each other. If the lines are crowded or denser, the electric field is larger. If they are far apart, then the electric field is small.